A scientific research institute for biological substances was established in 1991 by Dr. Sova. In order to maintain financial independence and fund research, BOOS manufactures and sells various enzymatic natural products produced during target research and development. BOOS concentrates on the modern production of immunizing non-bacterial preparations in various cosmetics, natural enzymes, skin products, and enzymatic cleaning and washing detergents. One of the most important inventions of this institute was the discovery of a special enzyme capable of breaking carbohydrates into water and carbon dioxide while concurrently decontaminating soil, water, and solid materials from the pollution. Traditional decontamination involves excavation of the polluted soil, which is then transported great distances to a hazardous waste incinerator or similar storage facility. Eventually, such polluted soil storage will become a new pollution source, thus never completely eliminating the pollutants. This traditional decontamination method is never a final solution and only delays the responsibility of obtaining a clean environment for next generations. In contrast, an enzymatic decontamination is capable of splitting hydrocarbons not only in petroleum substances, but also much more complicated chemical compounds such as cyclic hydrocarbons, PCBs, DDT, phenols, cresols, etc. The finished product is not a secondary pollutant, but simply carbon dioxide and water. This is a final solution. How is enzymatic decontamination done in practice? The first example from 1999 shows the process of decontamination of gas stations in the Netherlands, where there is no place to store excavated polluted soil. 5 gas stations were simultaneously decontaminated, wherein one stone paving every 6 feet was removed, and a shallow hole, 1 inch wide, was drilled into 3 feet deep. The holes were foxed with plastic tubing and then filled with the enzymatic working solution, an enzyme water mixture where 1 liter of enzyme is diluted with 1,000 liters of plain water. The water may be used from rivers, creeks, sea, or whichever water source is available. Approximately 4,000 liters of the enzyme solution was absorbed at the pumps the first day, another 2,000 liters the second day, and a few hundred liters on the third day. Area surface is sprayed with water to avoid evaporation of the working enzyme solution. The enzymes were left to work for an entire week with no activity required from the crew. Massive concrete surfaces are drilled in much the same way, with the same process to follow. The ground absorbs as much enzyme solution as it needs for saturation. This procedure is repeated until the pollution levels fall below the required level. During such decontamination, the cars can continue to tank gas, and the service of the gas station does not need to be interrupted, thus not resulting in any lost business for the owner. At the end of decontamination, the tubes remain in the concrete and surrounding area by way of a permanent system for decontamination. This installation at such a gas station can be used every time for future decontamination by simply applying the enzymatic solution to newly opened holes with tubes. It is important to note that no underground electric, hydraulic, or other lines were damaged in this process. The decontamination process also does not cause any damage to the environment. Enzymatic decontamination has a very wide possibility of use. Another example included a field near a steel factory which was polluted by PCB up to 20 inches deep. A spray of the enzymatic solution resulted in 0 PCB detection in the soil or surrounding flora. In another example, oil pollution was removed from concrete surfaces. If contamination is not deeper than 60 to 70 centimeters, plain spray can penetrate to the depth and spread of undesirable substances and travel to the desired decontamination site. The same situation occurs at railways, where a simple spraying will eliminate pollution up to 50 centimeters or 20 inches deep. As shown in the next example, decontamination can be achieved by spraying directly onto unlimited miles of railway tracks. If pollution is in concrete surfaces, then spraying them with the enzymatic solution eliminates pollutants. Also, penetration of enzymes is effective down to 20 to 28 inches into the concrete, and the splitting of carbohydrogens is complete. Removing and replacing macadam is much more laborious and expensive. In the case of factory floors, for example, in a Volkswagen factory, the decontamination of concrete floors is realized by simply spraying the surface. These floors have a pollution sensor device. When no pollution is present, they are green. When pollution is present, they change color to light yellow-brown. Concrete floor assembly lines in the Volkswagen factory over time became contaminated with oil residue and oil products. Traditional methods required shutting down the factory, removal of all equipment and concrete floors, as well as the dirt below to the level of contamination, and reinstallation of concrete equipment and machinery. With the enzymatic method, spraying the floors achieved total decontamination. The next presentation was arranged especially for the Slovak Railway Company. The railways were near a depot and were extremely polluted by roe oil and its products. A 15-foot area of very dirty track was completely cleaned by applying the enzyme solution, which was heated to 104 degrees Fahrenheit to accelerate the enzymatic activity. After about 5 to 10 minutes, the solution was applied again using a rotating cannula. This video preview is in real time, not edited. The result is stunning. The tracks, sleepers, and blacktop look like new. In oil fields near Bratislava, old used pumping equipment was decontaminated. The pictures illustrate clearly the amount of pollution before decontamination and after. The Nafta Gabeli Corporation needed to remove old unused probes, which were heavily coated with years of oil residue. The company originally planned to clean the equipment with kerosene, diesel fuel, or gasoline, which would mean creating even more pollution of the land. These probes were completely cleaned by simply spraying the enzyme solution in just a few minutes, as you can see in the close-up view. The surrounding soil, also deeply polluted, was decontaminated with the same application. This amazing product makes it possible to clean a variety of devices, valves, pipes, and machinery, as well as entire refineries. The nearby fields had small lakes with water that had been polluted as a result of the raw oil pumping. The water had been contaminated up to 250 to 300 milligrams per liter, and the soil pollution level was about 150 to 180,000 milligrams per kilogram. The water, in comparison to the soil, was relatively clean. Therefore, a water circulation method was used instead of trucking in water. When the application holes were made, the water from the lake was used together with enzymes for soaking the soil. During the first 2 weeks of circulation, the water became so clear that frogs and tadpoles returned. Gradually, the area was decontaminated and the water and soil were restored to the desired levels. Contamination fell below the required 1,000 milligram per kilogram and the water below 20 milligrams per liter. The same method was applied to mining fields where similar pollution problems exist. The last example is from Spain, where after an oil spill catastrophe from the Prestige ship, rocks at the coast were black and full of bitumen, a hard, raw oil sediment. After securing the approval of the Spanish government, we proceeded to use high-pressure cleaning machines where again an enzymatic solution, 1 liter per 1,000 liters or 264 gallons, with water was heated up to 40 degrees centigrade, 104 Fahrenheit. The vapor around the workers is not steam, but the solution spray only. At the request of Spanish broadcasters, we cleaned only one part of the stones. A comparison of the before and after stone coloring is striking. The whole event was documented by national Spanish television news. The decontamination continued at the beach, too, where we simply sprayed the sand. The result? In 1 week, the birds returned to the beach. In the past, cleanup methods were time-consuming, difficult, expensive, and often created even more pollution. This is a product of third millennium technology with far-reaching environmental benefits. The profit margin is much higher, and the investment of labor and equipment is much lower than traditional methods. Please call for a free presentation and demonstration.